So now we're about to go through CloudCar installation procedure. Doesn't require any understanding of OBD protocols. All you have to do is take the OBD cable and plug it in under the dashboard, and it goes through a post routine using the driver information center to report feedback. OBD active, GPS active, cell active. CloudCar is good to go. When we set out to build CloudCar, we wanted to build a platform that would be extensible and support a wide range of applications, but we also didn't want to exclude OEM telematics systems from building applications. Here, we recreate the functionality already present in many systems such as OnStar. We have a little web-based application on my phone here, and we can see it gives a little bit of feedback. Lock status, the car is unlocked. The car is unlocked. And in the application, we're just going to tap the lock icon, and then it'll take a second because of the network delay. There we go. And back to the application. And locked. We have confirmation. So that's great if you're walking to the office and forget to lock your car, or you think you might have left it unlocked. Here we see our Teen Tracker application. In the iteration shown, we're demonstrating a reconfigurable virtual dashboard. This is great for parents who want to know where their children are. It's also great, for example, if you're running late to a meeting. You finally have evidence to tell your boss why you're running late. Here we're replaying data from a previous trip. In testing, we noticed approximately a 10-second delay between recording the data and being able to visualize it on screen. Despite the wealth of information available, bandwidth use is actually very low. At the same time that we wanted to provide a platform that would allow OEM telemetry systems to recreate their applications, we wanted to build something that would provide for new and more exciting applications. So let's say that you live in a very hot climate and you like to leave your windows down, but there's a rainstorm coming and you're trapped in a meeting. Well, CloudCar will actually scrape a database from a website, like Intellicast.com or Weather.com. The user can actually choose which website they scrape the database from, and it uses GPS coordinates to ensure that the weather data is accurate. If you determine that there's a rainstorm coming, the car will automatically roll up its windows. Of course, you can also do this with pressing a button using an application similar to the locking app that we demonstrated. And when the windows are up, it sends a notification to the user from CloudCar that says that you parked in an area with a high likelihood of rain, and CloudCar has closed your windows for you, but you can disable the feature in settings. It does use the existing sensors in the car, so that if there's something in the way of the window rolling up, it won't get trapped. So building on that idea of scraping databases, we can take advantage of the additional sensors that the CarKnow CANPuter has to offer. In this case, imagine that you're a driver who frequently travels long distances for work, but you're always traveling to a new location. You really like listening to NPR, but you don't have XM radio. Well, using the GPS coordinates in your CloudKnow CANPuter, we can scrape a database based on your current location and automatically update your radio preset, so that no matter where you are, preset 1 is always NPR. You can see that my hand isn't on the steering wheel and isn't on the radio here, but as I'm about to cross the GPS boundary between Station 1 and Station 2, it will change automatically. And we go from NPR 1 to NPR 2. No intervention necessary.